Okay, we have four different gas supplies. Helium, that's the carrier gas for the GC column.
Okay.
We also have air and hydrogen. They're both the gas for FID detectors.
Okay, and FID stands for flame ionization. So you're burning hydrogen with air to get a flame.
Okay, the other gas we have is nitrogen. It's used as a makeup gas to fill in whatever gas deficiency in the FID detector. Now, the real consumption is air because our FID consumes 450 milliliter per minute on air. So this guy has to be replaced as often as possible. There are gauges on the top. Usually, once you replace the gas, you don't need to change. Well, you know, you can leave the screw here on top here open. But for air, usually I would just turn it off after done the analysis. The point is I want to make sure there's no leaking here. So you can see we're running pretty low on gas now. This one has to be replaced. When it has a pressure lower than 400 psi, you definitely want to replace it. Otherwise, you're going to have some impurity residues in the air. All right. Two things usually you want to check. One is the fitting here. You can see the Teflon tape inside. That's when I put the gauge up. Right? I wrap it up with Teflon to make sure there's no leaking. The other one is actually the coupling here. You can check it with soap water. Just dip some soap water on there. If there's a leaking, you can see a bubble forming up. All right. And once you have all the gas ready, then you move to this direction.
Okay, so then we move to the GC.
Right.
Here's
Before
the
you
GC.
turn up, now there's a front panel on the GC which tells you what conditions the machine is in right now. All right. You can access that panel. You can control those parameters from the front panel here, or using a computer program called ChemStations. Right. But before that, usually this is the auto sampler for the gas chromatograph.
Right.
If you're not running, or you're not using auto sampler to handle that automatic sequence of samples, you don't need to use this.
Right. So when we're
Injection.
doing SPME fiber, we're going to put the fibers in directly.
Right.
So you would use this for when you have little bottles, and it actually does everything automatically.
Okay, you move it back here. Now you want to move closer here. There's a screw cap on top here.
A screw cap. Oh yes.
Okay, that green cap. You can move it out. You don't want to do it now because right now the temperature of this injection port is
Too hot.
220 degrees. Whenever you want to remove anything from here, shut down the temperature first. Wait until it goes below 50 degrees. You twist it. That's counterclockwise. Turn it open. There is actually a piece of septon like this one in there. You want to replace it every once in a while. If you're using auto injectors, you want to replace it like every 2 to 250 round injections. But if you're using manual injection, that injector I'm going to show you later, you want to replace it in every 50 injections. The reason is that the syringe opening of the manual injector is much larger
Oh, I see.
than the auto injector.
So when you run the Donna's and she's running 350 or something like that, you're not changing it in the middle, are you?
No. Now it's important because if that septon start getting a pretty big hole on it, you're gonna have helium just leaking from here. Then it's not actually the gas supply is not going through the column. Then the other thing is you want to check front inlet. All right, like the temperature. I conditioned the column and all the other compartment already this morning. Right now the temperature is 250. The pressure should always be
250
up.
or 220?
Oh, I'm sorry, 220.
Okay.
But the pressure should always be more than 10. That's PSI here.
I see.
Right?
So you pushed front inlet to check the pressure.
Right,
Okay.
front inlet. Okay, if you want to switch parameter, there are arrows here.
Okay.
Right? Then you go to oven, which tells you the programming of the last method ran by ChemStation.
I see.
Right.
We'll have to explain
running a
to Dan
10
how that
here,
works.
right.
Okay, so we can
Okay.
do that
And the other
later.
thing you want to check is front detector. Right now,
Now the front
hydrogen
detector
flow,
just means because we have two detectors, and the front one is the FID.
this is the front one.
Right, it's in front.
All right.
Imagine that. Okay.
The temperature is always set up at 275. Of course, if your method requires other temperature, you can do so accordingly.
So right now we have no hydrogen flow
No.
and no airflow
Shut
because it's
it
not
off.
turned on, right?
Right, right. And hydrogen flow, air flow, they're all turned off at the moment. And the mode is constant makeup this gas flow at fixed rates. And you have makeup gas, nitrogen, should be 20 milliliter per minute. Flame is off. So before you access ChemStation, what you want to do first is turn on flame.
Okay, wait. How did you do it? So you were on the detector. So the front detector
Right.
chosen, right?
Right.
And then you went on.
Right. Okay,
Oh, and now it
I
says
can turn it
igniting
off so you
flame.
can see
Okay.
it again.
All right. So wait. So the on is down here, and then you see igniting flame here.
Right. If you turn the hydrogen flow and airflow up first before you're turning on the flame, the flow is going to shut down. So you always want to go down, find the flame first,
So you turn the flame on first,
right?
and then you turn
But don't
the.
wait too long. You want to turn it on all in sequence and rapidly. See?
So then you got to turn the hydrogen and flow. Okay.
Right?
And you taught. How did you get to the hydrogen and the airflow? By pushing the arrows.
Right, push an arrow going up.
I see. Okay. Okay.
So this is why air consumption is pretty high because the flow, as comparison to others, you can see
Right.
it's a pretty big flow rate. Then the next thing you want to see, well, I want to go to signal 1. That's the signal from the FID.
Okay.
All right, right now it tells you the baseline has a unit of 4.9. It's pretty low, and that's pretty good. We're happy because I conditioned that this morning already.
Okay.
Otherwise,
Meaning you've had the column sitting there warming up for a little while with gas flow.
I'll get into that in a minute.
Okay.
If it's above 5.5, you technically want to recondition a column in the FID detector.
So now why is it jumping around?
Yeah, see, that happens every time when you just reignite the flame.
Oh, I see.
But in a
okay.
while, it's going to
It'll
come
settle
back
back
down.
down.
Right.
Sure. Okay. That makes sense.
Okay. And the next thing you want to do is go back there. If you need to condition your column, you might as well actually condition the injection port, column that can be accessed by oven here, temperature, and FID 275. The temperature I usually use for conditioning for front inlet is 280.
280.
Yeah.
So you condition it 280 with
Right.
a flow rate of, with that same pressure.
See, you type in
280.
280.
I
Enter.
see. And then enter.
Right?
And that takes the front inlet means the inlet to the front column.
Right.
Right. Same thing. There could be as many as 2 columns. One's in front, one's in back.
Mm-hmm.
We only have a front.
Right. Then you go to oven. I usually use 290. It's important for this particular column never go beyond 325 degrees Celsius. Right, that's going to ruin the column coating. And for the front detector, I use 300.
This is just for conditioning?
Just for conditioning.
I see.
Now, if you haven't
Now,
reconditioned
what's our helium? I mean, we want to be sure anytime you're conditioning that you have gas flow through the column.
Right.
So how did you set the helium flow? Did we see that?
Okay. You'd actually go to column.
Go to column.
Right. See, the flow is fixed.
Okay, at
Right, that's the
3.5,
helium flow in the
3.5.
column. Right.
And that was fixed. And you could change it here on the front panel if you wanted to, or
Yes,
not. You
yes.
could.
Well, the other important thing is once you activate ChemStation takes over all the control.
So then all of your front panel controls what you've done
Some
there
of
won't
them
matter.
still are functioning, but you're confusing the computer program. Actually.
Right, I see. So in fact, you probably shut these down somehow.
Right.
Okay, we'll talk about that.
All right. And okay, if you haven't conditioned the machine for quite some time, like when LaDonna is running her analysis, I usually condition it for 1 hour. Then I lower the temperature of the injection port and the FID, and I go on and let the column conditioning for another hour. But if you constantly condition all the compartments, actually 30 minutes will be good enough. Right, so I'm just
So let's explain to Dan what conditioning is. What you're doing when you're conditioning is sometimes you've had, instead of like cleaning up your engine, you've had buildup of stuff over time. And so you're raising the temperature usually above whatever temperatures you're going to use in your procedure for doing the analysis
See,
to kind
signal one is
of
coming
get everything
down.
either to burn off or to desorb and be gone.
See, right now signal 1 is coming down. Remember, it
Right,
just
because of
went
the
up.
flame just being lit.
Right. If the column is pretty dirty or the FID is pretty dirty, usually you have a number going down above 20. Don't panic, that's normal. It will come down in a few hours. Well, 20, 30 minutes.
Okay.
Alright? Since I already conditioned the column this morning, so I'm just going to tell you to go, well, this is what I want to show you.
Okay.
You don't have to use manual panel. Well, you could do it that way, or go to Program,
Should have brought the,
HP ChemStation.
Okay, HP ChemStation, yeah.
Alright. The one you will be using is either instrument 1, that's gas chromatograph. Instrument 2 is HPLC. Online means the station is in in operation mode to control the gas chromatograph. You can also use offline if you just want to adjust and see your chromatographs.
Right, so your data.
Right,
So instrument 1 online
right,
is the GC.
right.
So you're going to select that. So it's
Then
really
it's
nice actually
activating.
because you can run it all right here from the computer.
Okay, watch out for the front panel.
So meanwhile,
It's going to change. See, it's
It
saying
says
ChemStation is
loading.
loading now. And in the meantime, the parameters stored in ChemStation will be from whatever method you use in the last operation. And it's going to feed in those information into GC. See, the temperature is coming on now.
So we're back
what
to
it's
the
showing you is the
ChemStation.
parameter. It's showing
now
you
let's
this.
see if I can focus on this. This
Okay.
actually, I think that's. It's always a little tricky focusing on computer screens. We'll see how that is. Okay.
Alright, so the parameter it's showing you here is from the method I used this morning, or whatever method you used in the last operation.
Right.
If the connection is somehow wrong or the machine's not ready, you're gonna see red, red, and red. When they're all green, just green light, ready to go.
I see.
I'm gonna
So,
show
wait.
you.
So your method was called SPME FRNP.
That's for method.
For naphthalene, okay.
Right.
We got it down now. And .m stands for method, right? Is that what that?
Right.
The .m and
Right.
.s stands for sample or something?
That's for sequence. If you're using auto sampler.
Oh, okay.
But if you set up your method to use manual injection, that sequence becomes invalid. It cannot be used anyway.
There we go. Oh, now it's in focus.
All right. Let me show you real quick.
So you're going to instrument. Okay, go ahead.
Instrument. Edit parameter. I'm not going to edit anything. I just want to show you. Oh, well. I won't be editing anything. Just
Okay,
want to show
you're
you.
just going to show it to us.
All right. That's where you put in a description for your method. Like this one is for naphthalene analysis using SPME fiber with manual injection in the FID.
Right.
All right, you want to specify using manual injection. Once
Right.
you choose this option, like I said, that sequence option becomes deactivate it.
I see.
You cannot use it
Because
anymore.
yeah, the sequence option only comes into play when you're using the manual injector.
Right.
That's when you tell it the sequence of what samples it will sample.
You want to use from location. That is this guy here.
Oh, it's right. There's two
We didn't
injectors.
configure, yeah, the back injector. Then it goes into this screen. Actually, you can access the same screen by instrument, edit parameters. Right now, you want to make sure the injector is not selected as the injection source. Then you can discard these little boxes here. That's for auto sampler.
I see.
Valve, make sure make sure the on box is not selected.
Okay.
That's for if you have a cryogenic injection port.
I see.
Inlet, we're using subless injection mode, right? Carrier gas is helium, temperature, pressure. Actually, the pressure would change during the analysis because we
You're
have
changing the
increased the
temperature.
temperature there.
So splitless just means that we're not bringing in another gas that's splitting, and only a portion. In other words, we're sending the whole gas sample to the column. You can operate where you're only sending a portion of it.
Okay. Column, it's a constant flow from, well, both inlet and jet detectors are from. The important thing here is make sure the flow rate 3.5. All the other parameters will be automatically adjusted accordingly.
I see, okay. Detectors.
Oven. Okay. The set point, never mind. That's just the starting temperature. Alright. So here I set up to have it at 45 degrees for 3 minutes. The reason for SPME analysis, you always want to have a steady temperature for 3 minutes. The idea is that when you have the fiber in the injection port, it will be thermally desorbed. The chemical will be thermally desorbed from the fiber. All right, the 45 degrees is just the temperature in the oven.
So that just keeps it sort of sitting at the front of the column,
Right.
accumulating. So
Right.
it may take it a little time to come off of the fiber, and you're letting it accumulate at the beginning of the column. Okay.
Okay. Then I run a temperature at a rate of 25 degrees per minute.
So pretty fast.
Right, let it go all the way up to 220. So the total run is
So that's
10
what you
minutes.
use for naphthalene. Do you use the same program? I mean, you go to 220 for phenanthrene too?
No,
Okay, so we can look.
205.
Oh, you don't go as high.
No.
Oh, really?
For
Okay.
4 flow, it's even shorter.
Okay, so we'll look at that later.
Yeah. Oh. Well. I'm sorry. Let me go back here. Detector. That's the detector parameters here. Don't get me wrong, you can still access the front panel. But like I said, if you change anything here, the program is going to ask you if you want to save it later. Between jobs, sometimes you get confused.
I see.
Signal 1, we have only one. You want to save only signal 1. That's for the front detector.
Okay.
Okay, the other thing I actually want to show you is column. Right? If you're looking for column information, they're right here. Now this particular HP1 column likes hydrophobic compounds, okay, organic compounds. So it's a pretty bad thing for this column to shoot in water.
Right. Water has other problems with this anyway that we can tell you about.
Okay.
So as a general rule, we don't put water in RGC.
Right. All the auxiliary channels should all be off in this case. Now pressure aux 3, 4, and 5 actually is for this machine, gas-based analyzer, okay, because it's using the same helium as to operate a pneumatic pump.
So we're not operating those,
No.
right? Okay.
No.
Runtime
Oh, these
options.
are all good. Yeah, these are all good.
Okay,
These are
so-
just standard settings.
Okay, so that's all set.
Alright. Okay, that's just for your selection about the rejection criteria. Like able to reject, I choose 0.1. Actually, you can go as high as, for naphthalene analysis, you can go as high as 0.5 or even 1. Alright, make sure you select both printer, screen, and file. Unless you don't want the hard copy printed out, then deselect the printer. But it's a good idea to have a hard copy. Alright. The results should be quantitative based on area, peak area. Okay, you want to deselect all the macros. Macro is a little program you can write. Like, before you come in this morning, you can tell the machine when to start the ChemStation. Or after you're done with all the analysis, you can write a sleep program for the machine. I don't know much about this language. So. Okay, after that, you save method again. You can enter the comment, just type down any additions or changes you made to the method.
Right, okay.
Right? Then the machine is set up and ready to go. See, like I said, the signal will come down. It's only 5.2 now.
Right, okay, good.
Now, when you have between 5.5 and 6, it could happen if your samples are not very clean, but it's still right. But if it goes beyond 6.5, you definitely want to condition it first.
Okay.
Alright? Now usually the data recorded. Now watch this part, it's called default file. D means data file. Alright? Somehow they screwed up ChemStation, HP people. They haven't debugged this problem yet. So what you want to do is, let me show you. See, that's HP Windows
Chem.
HP Chem. 1 is for gas chromatograph data.
Yeah.
Now, usually, if you're using auto sampler, you can name the sequence, name the number, give it the name for your data file.
I see.
But if you're using manual injection, you always go back to the default file.
I see.
Which means when you're done with this one, you got to transfer this somewhere. Otherwise, when you run the next sample, it's going to override this one.
I see.
Then you lose all your data.
So you have to so you need to name it.
Right.
And do you have to go into the folder to name it? You can't name it from. That is bad, isn't it? It was like super expensive. I mean, this software costs thousands of dollars.
See, this is the secret hideout for all my GC.
This is your hideout.
See?
I see. Okay.
All right. And LaDonna has her file here. Yeah, 9 runs analysis. Oh, look!
Oh, wow. Wow.
This is the last one. This is a real big one, see?
400 and something?
She had more samples on this run. So.
I see, okay.
So keep in mind for manual injection, you gotta move the file after every single shot,
now,
otherwise it'll be lost.
We don't back this computer up with respect to the data. We have full backup on all of the software.
Right.
But so what you want to do, what we'll want to do is be sure when you're finished a bunch of sequences runs that we back up to the zip.
Okay, one thing.
I mean, we don't normally have crashes, although we should warn you if we've been having trouble with the hard drive on this machine.
The other thing is, once you have data file generated here, because the size of them are pretty big, you want to go to D drive, set up a directory or folder for yourself, and move all your data files.
So all the D drive is sort of the where the data are, all, where you like to store the data.
Right.
So you're just going to move them.
Because C drive is formatted for only 2 gig only. So
right. So that's where all the software sits. Okay.
Another thing you want to note is, when you're using ChemStation, try not to use, unless you're doing manual injection, it's unavoidable, but try not to use Windows Explorer while this program is actually in progress. Like right now it's just standing by. It's not running anything at all. Alright, that will be it.